It's 10:05, so we are now going to get back into our session. If you've been wondering what we've been doing, we had a person that wasn't able to make it at 10 o'clock, so we're going to go right in to hear from Kate Harms on her project. She is from the Rodale Institute, looking at investigating bat activity in various agricultural landscapes, and this is a Northeastern NESARE funded project. So Kate, go ahead.
Okay, can everybody hear me and see me then?
Yes.
Okay, perfect. Yeah, this project, you know, like he said, it's been funded by Northeast NESARE. We actually did get a little extra funding from the Ian Somerhalder Foundation as well. This is looking at bats as IPM, and especially for organic farmers. They're interested, farmers, after talking to them, they're interested in using bats for organic IPM, but they admittedly lack the knowledge. And I think that's the big thing out there. We know bats can help remove a lot of insect pest pressure from agricultural systems. We just don't know how to attract them. Also, the Northeast, we are seeing our bats being decimated by white nose syndrome. So in my mind, it became more of a priority issue to do some of this research to find out how we can continually support those populations and you know, bring farmers on board so that the farmers can use those services as well. You know, it'd be nice if we could harness the power of bats and also provide some conservation for them. There are success stories of farmers who have been able to reduce pesticide applications that have gotten what you would call maternity colonies. They're when all the female bats will rear their young in large areas. So one of the things they can do are use barns or artificial structures like bat houses. So if we could find out how we can draw them in and there during their you know, point where they're going to be having offspring and they're going to have these voracious voracious appetites, what we can do to kind of increase that. One thing we also wanted to see is how bats were acting with where you would find them more and what commodities and what the landscape did to affect that. So the project design that I came up with was we were going to look at orchards with tree lines and orchards without tree lines. And we're also going to compare conventional and organic orchards. We're going to look at vegetables with insectary strips and without, and again, looking at vegetables, conventional and organic. And then the same thing with grain crops with tree lines and without tree lines, looking at organic versus conventional. We also threw in vineyards, nature preserve, ponds, and riparian areas as well. This was the first year, it's a 2-year study. The first year, we put up a bunch of different bat houses as well. We are looking at 3 different models. We have a 3-chamber, 4-chamber, and 7-chamber bat house to see which ones will occupy the fastest. Bats usually won't move in the first year. You want at least 2 years, so that's why it turned into a 2-year project. And no, we don't have any occupancy yet in the ones we installed, so we'll have to wait to see what happens next year. But that's also to give farmers an extra tool to say, okay, this is what in the Northeast is the most effective bat house. This is how they're using them. They may actually jump between the different bat houses depending on temperatures. The reason why the sizes are different is because if you're gonna install a bat house that's not on a structure like a barn, they want thermal stability to raise their young in. So if you have something bigger, it's going to create more thermal stability. You're not going to have these big temperature changes with night and day, and that is important to them. So we're looking at those models. When we looked at all the data we collect from the activity in these agricultural areas, and let me clarify that, when I said how we're going to be, because this is, I know this is a little different than a lot of you guys are used to for IPM. We did this with acoustic monitoring equipment. So we deployed these microphones that would pick up on the ultrasonic echolocation calls of these bats. And we have software that we can then figure out what species of bat it is, and you can count how many bat passes. So we looked at how many bat passes in an hour to estimate the bat activity. With those results that we got from this year, now we have to run our stats on them, but we are seeing a big trend with tree lines, which was kind of expected because bats do like the tree lines for safety, for traveling corridors, and also roosting as well. And the interesting part is we're actually seeing tree lines are even effective in orchards. So an orchard is, you know, literally a group of trees, and yet the tree lines, the native tree lines, are being effective for attracting bat activity as well. And when I say attracting bat activity, we measured the activity actually over the orchard. So it wasn't like we were right next to the tree line, looking into the tree line. This is actually bats are actively feeding over the orchard, and they're doing it in areas that tree lines surround these commodities. So that's what we have found out so far. Another thing that started to spur off at the end of the season, now I didn't have time to go ahead and finish it because the bats, we're losing some activity going into winter. They're either migrating or hibernating. But I did look at how much it decreases the further you get away from the tree lines. So I went ahead and did a few more nights, and I was looking at the differences between 50 feet and 150 feet away from tree lines to see the different decreases. And I'll hopefully I can find extra funding to continue that. We also want to find extra funding to study the guano so we can actually look at the bats that were foraging here and look at the pests they were eating to make a better connection, and also do some pesticide residual testing on the guano as well. And as of whether or not organic and conventional made much of a difference for bat activity, we did not see any concrete data on that. It may have been that the areas we looked at weren't matched as appropriately as we had hoped. There's just too much variation in them. But tree lines were very effective at this time, and we're going to wait till next year to hear about the bat box occupancy. So
okay.
That's pretty much it.
Thank you, Kate. Very interesting work. And we're going to move right along to Darcy Telenko, and she is with the Cornell Cooperative Extension Vegetable Program. And I'm going to talk about minimizing wildlife impacts on yield and food safety risks in vegetables. And this is a NESARE NYFVI project. I don't know exactly what that is, but anyway, so Darcy, go ahead and let's hear about your work.
Yes, so this was NESARE, and then New York Farm Viability is that acronym, who's funded the project for another 2 years to continue to explore some of these options that we're looking at. You can just move to the next slide and I'll provide a little background of what we're seeing. So what we've been mainly looking at lately is bird damage, and it's continuing to be a persistent problem for our vegetable growers. And then also the potential for microbial contamination with wildlife in the vegetables. In a 2014 survey, we had 84% of our growers reporting bird damage in their sweet corn with a loss of about 16% in yield. So this kind of initiated the project to try to see if there's any tools that we can try to implement that may help try to minimize this loss. We had growers stating they had problems from the day they planted, with some farms reporting a loss of over 5,000 ears. So that's the background of what led to this project and our continuation to try to evaluate these options. As you can see here, we're in a sweet corn field this summer, and you can see the flock of redweed and blackbirds taking off right when the corn is prime and ready to be picked. If you move on to the next slide, the techniques we're looking at is reevaluating methylanthrinolate, which is available as avian control. This product's been around since the 80s and tested in various systems, but we wanted to see maybe if it's more a timing factor to utilize this to try to minimize the birds moving in. We're seeing if we can get it out early, we might be able to keep the birds from moving into the field at all. We also wanted to look at an air dancer. We've been, with the air dancer, we've been running it both on generators and electric. Right now, running it off electric is the easier option instead of having to fill the generator daily. And it provides an organic option since the avian is not available organically. And then in addition, we also went to look at detasseling sweet corn and seeing what would happen if we took off the perch site for the sweet corn, and then compared to some hawkeye balloons too that have been useful in some of our grower sites. So those are the 4 treatments we were looking at this season, where we expanded into different areas. I think if you flip to the next slide, we'll give a brief overview of what we were seeing. In 2015, we had 5 farms that we looked at these different treatments. You can see there's high variability. The amount of ear damage that we received under the sites, up to 30% ear damage at one location. But many of the sites we're seeing where we're applying the treatments, the birds are avoiding the whole field. We did have some variability in the effectiveness of avian. At one field, we actually saw the damage increase, but then when we went back into another field at the same location, we did see a significant reduction in ear damage with the avian control, and both the air dancer and balloons seem to be consistently helping to scare the birds out of those areas. For 2016, we didn't quite see as much ear damage occur in our field locations, even though the damage seems to increase around the area, especially with the drought conditions. We've had a lot of reports of a lot of wildlife damage in addition to the birds. We do see that where we were treating with avian coming in at 3 weeks and 2 weeks prior to ears being picked, we were able to keep the birds out. And I think that's the one important thing using the chemical control, is that we got to get in there before the birds discover the corn and want to feed on it. So it's being proactive instead of a reactive treatment. Detasseling worked relatively good, and some of the growers that we're working with are excited about possibly using that option. Because you know, there's limitations on the air dancers finding electric sources or energy sources to run them, and field size. So one air dancer we found is probably a 50 by 50 square foot area, and that's not going to work if you have 2 to 3 acres of sweet corn. And again, we also were seeing that some of the balloons were working relatively effective. So next slide. So in summary, we're seeing some success, but it's dependent on the application timing and placement and crop maturity. We're not going to have success if they go in after the birds have discovered the sweet corn to feed on. Some are implementing these techniques in addition to what they've already been doing, and seeing that they work, especially in areas where they have consistent problems year after year. I think the importance of what we've learned is we got to maybe look at disrupting their nesting sites and then trying to get them to avoid the susceptible areas. And I think that's it, Listen. You can answer questions.
Thank you, Darcy. Last year I remember the dancing man. So interesting work that you're doing. And we're going to move on to hear from Donna Ellis. She is going to give an update on she's from the University of Connecticut. She's going to give an update on the CPPM-EIP program, and that is the Crop Protection Pest Management Program funded through the USDA. So Donna, if you're on and your slides are up, you can go ahead and get started.
Great. Thanks, Steve and Yana. Can you hear me okay?
Yes.
Great. Just wanted to give everyone an update on our IPM program for Connecticut. We are appreciative of the funding we received from USDA NYFVI, and we also received some funds from USDA APHIS for a few of our projects. The Connecticut IPM program team is made up of 9 members. Most of the members are active in some capacity with the EIP project, with the exception of our vegetable program. You can go to the next slide. Mary Conklin does our tree fruit and small fruit program. She works season-long with a number of different growers throughout the state, providing hands-on training, teaching them about scouting and IPM techniques. She does separate messages each week for tree fruits and small fruits. You can see some of her activities here with a few of the winter programs she's done and summer programs. That's Mary on the left slide. A couple of trapping trials for brown marmorated stink bug, spotted-winged Drosophila, trying to find the most effective trapping protocols to enhance tracking pest populations. She also has been working on a fertilizer study with tree fruit growers and had good participation with that. Joan Allen does all of our diagnostics for the IPM program, and also to a greater extent for the Home and Garden Education Center at the University of Connecticut. Many of us that do work with growers will bring specimens to Joan. She is a plant pathologist, but she also will give recommendations for other pests as well. And she does very nice detailed reports that we share with our growers so they can learn what the pests are and what some of the management recommendations are for them. Next slide. For greenhouse IPM and also with perennial plants, Leanne Punt is our extension educator. Leanne has been with the program for a number of years and works with both wholesale and retail greenhouses. She has been really trying to promote biological control and has seen great success in the greenhouse over the last few years. She has been presenting annual summer conferences on biological control that have typically been attended by greenhouse growers. The last couple of years, she's also been expanding that interest and that application to nursery producers, garden centers, and promoting banker plants and trying to not only enhance natural enemies at the growing sites, but to introduce beneficial insects as well. And so that is really, it's just starting to take off in our state, but we're hoping that we have more and more growers that will participate. Alejandro Chiriboga is our extension educator for nursery IPM, and he and I work together to provide, again, full season training programs for nursery growers, also wholesale and retail growers. You can see some of his statistics from the 2015 year. This past year, Alejandro and I worked with 6 growers around the state and worked with them to provide training and help them to produce healthier plants overall. He does some of his programs in the wintertime. He does work also with some of the greenhouse growers as well. Next slide. We have a school IPM program in Connecticut. It started back in 2010 with some funding from the IPM Institute, and Vicki Wallace and I are the co-chairs of this. Candace Bartholomew had also been active in it, and we've had the participation of Alejandro and a few other IPM members over the years. We primarily are providing information on how to take care of pests on school athletic fields, landscapes, and other school grounds without being able to use pesticides. In 2010, laws were enacted that prevented school grounds managers from using registered pesticides. We provide this information via annual summer workshops. We do twilight meetings. We have developed assessment forms for both athletic fields and landscapes to try to gather that information and use that data over time. Weather stations have been installed not only on school grounds, but also Mary Conklin with the fruit program has been installing weather stations around the state to gather additional data. On the right pictures on this slide, you can see some of the biological control work that we are involved in Connecticut, working with Carol Chia, an entomologist with the Connecticut Agricultural Experiment Station for mile-a-minute weed biological control, where we've introduced the beneficial weevil rhinon Chamaemus latipes. We're up to about almost 50,000 weevils released in 24 towns around the state, starting to see the weevils established, and have been very happy with the results to date. Next slide. You're going to be hearing from Anna LeGrand shortly. Anna is also a part of our IPM team, and she conducts, as one of her programs, Community and Urban IPM. They provide training in some of the towns around the state for Hispanic adults teaching urban agriculture. She has also done a number of workshops on biological control and white grub biological control, and has had a lot of interest in these areas. And then finally, to sum up, Candace Bartholomew oversees the pesticide safety education program for the state. Candace sets up the several ornamental and turf short courses that a number of us in IPM serve as instructors for, and we provide training for those who are soon to get their pesticide applicator licenses. Candace also is in charge of basic pesticide applicator safety programs, which we try to incorporate into all of our training programs as much as we have time. I think that's about it for the UConn Connecticut IPM program.
Great, thank you, Donna. That's a really nice snapshot of the program. Really interesting to hear that. We do have 7 minutes, so, and we didn't hear from Kevin. I got an email that he's online. Can we bring up his presentation? Kevin, are you, Kevin Rice, are you there?
Actually, I'm not seeing Kevin online in either the viewers list or the panelist list.
Okay, I just saw that in the chat box that he was there, but let's if there's some discussion, I guess. There was a question for Tom, and he did a really nice job of answering that in the chat box. Anyone else? I would encourage you to use the chat box. I guess I had a question for Darcy. You know, the thing that you showed with, and I hope you're still there, the thing that you showed with your data for 2015 to 2016, it was very somewhat striking, and you know, and you attributed that to drought. Is there any, have you looked at, you know, what the birds are doing? Are they responding differently? I mean, they're a very kind of interesting pest, if you will, but you know, are they going somewhere else? Are they, you know, is that not something that you're investigating that, you know, in depth?
We're not looking that in depth. I guess the biggest difference we were seeing is what we're finding is the problem with this doing research with bird data is that they seem to avoid the whole field when we put out the treatments. So they're still feeding the next field over or causing like 80 or 90% damage in some of the trials right next to where the trial was. So,
Okay.
but I was showing, we have what I was showing is the untreated damage within that field site. And so I've actually collected other farm data. I haven't analyzed it all yet, looked at it yet.
Mm-hmm.
I'm trying to look at the movement into the fields because they were moving in. We have one of our sites, like the next plot over that was ripe 2 weeks later, they lost 2.5 acres to bird damage.
Wow.
That moved in. So they're there. It's just trying to quantify that within a trial set up with the untreated control right in that field plot. And, it's bringing in the other field sites, but then you bring in the variability of crop ripeness and if they've used different varieties.
Yeah, what species of birds? Are these mainly one, or are they several different types, or what?
There's many. I'd say the red-winged blackbird is one of the worst ones that we see the big flocks of. That was the picture I had of the red-winged blackbirds. But there's grackles and other blackbirds. In that area, I mean, it depends where we are, what the birds were. Those were the two main ones. Is that red-winged blackbird is the one that's been a problem right in this western part of the of New York.
Mm-hmm.
But there are various different, some people have problems with the crows. And then there's they can't really do anything other than the scare tactics with these migratory birds anyways.
Right. I was in, so Cornell has the Lab of O, which is obviously, well regarded and does a lot of work on birds. I guess I would wonder, is there a difference in their level of intelligence, and, are they like sensing, oh, we better go to this field or not go to that field? I don't know. It's a very interesting question, around this whole pest topic, because birds we don't often think of as being this really, bad pest, but I guess from your work and from what we've seen elsewhere, it is not. They can be an issue.
Well, I think it is a learned factor. They do know, they learn that if the chemical causes them to have a bad reaction, the idea is that they learn not to go there.
Mm-hmm.
So then they learn to go away and go to another site or, find another crop. A lot of our growers talk about once the oats come off, the birds seem to move away out of the sweet corn.
Mm-hmm.
But when there's zero tolerance for damage in the sweet corn, especially in the fresh market, that's where we run into the problem of even a little bit of damage of them feeding is a big issue.
Mm-hmm. Great. Well, I appreciate that. And I wanted to also follow with Kate. If you're on, you were at the end, you said you didn't see any difference between conventional and organic. Do you think that will change? I mean, so you've been doing this for a year. I mean, this study, but do you anticipate anything changing, going forward between the two systems?
Yeah, I don't know at this point because, we pretty much are out of the funding for this project for the most part. So I don't know if we'll get to look into that further. There are other studies that did show that made a big difference, and some of them have even been done on this farm compared with a neighboring farm. So I have to see what's going to happen. I think it's just being able to match the commodity areas up more appropriately, because some of the areas that we looked at that were conventional just happen to have large bat roosts nearby. I think that was affecting why the bat activity. So it had more or less to do with that there was a neighborhood nearby that had a lot of roosting areas, and then also the one conventional area that we had used as a comparison. It just wasn't. I think it just wasn't enough repetitions to pull a good conclusion out of.
Right.
It needs to be a bigger project, and we just didn't have the funding. It was a smaller grant, so I think if we expand on it, you'll see a better comparison.
Yeah, well, it's very interesting, and I appreciate that work because, again, that's, people don't think of bats very often, but I mean, they're an important part too, and I think, highlighting that factor is important, and I really applaud what you're doing. So
Well, thank you.